Chapter 8 Chemical Reactions. The fuel in our cars burns with oxygen to provide energy to make the cars move and run the air conditioner. When we cook our food or bleach our hair, chemical reactions take place. In our bodies, chemical reactions convert food into molecules that build muscles and move them. In the leaves of trees and plants, carbon dioxide and water are converted into carbohydrates. Some chemical reactions are simple, whereas others are quite complex. However, they all can be written with equations used to describe chemical reactions. In every chemical reaction, the atoms in the resulting substances called reacting substances, are rearranged to give new substances called products. In this chapter, we will see how equations are written and how we can determine the amount of reactant or product involved. We do the same thing at home when we use a recipe to make bread or cookies. At the automotive repair shop, a mechanic does essentially the same thing by adjusting a fuel system of an engine to allow for the correct amounts of fuel and oxygen. At the hospital, a respiratory therapist evaluates the levels of carbon dioxide and oxygen in the blood. Section 8.1 Equations for Chemical Reactions. A chemical change occurs when a substance is converted into one or more new substances. For example, when silver tarnishes, the shiny silver metal, silver, reacts with sulfur to become that dull black substances we call tarnish. A chemical reaction always involves chemical change because atoms of the reacting substances form new combinations with new properties. During the chemical change, there is usually visible evidence that a chemical reaction has taken place. For example, a chemical reaction occurs when an antacid tablet is dropped into a glass of water. The sodium bicarbonate and citric acid in the tablet react to form bubbles or gas of carbon dioxide. Other types of visible evidence of a chemical reaction are listed in Table 8.1. When you build a model airplane, or prepare a new recipe, or fix a medication formula, you follow a set of directions. These directions tell you what materials to use and the products you will obtain. In chemistry, a chemical equation tells us the materials we need and the products that we will form in the chemical reaction. Table 8.1 Types of visible evidence of chemical reaction. 1. Formation of gas. 2. Change in color. 3. Formation of a solid, precipitate, heat or a flame produced or heat absorbed. Writing a chemical equation. Suppose you work in a bicycle shop assembling wheels and frames into bicycles. You could represent this process by a simple equation. 2 wheels plus 1 frame equals a bicycle. The reactants are the 2 wheels in the frame. The product is the bicycle. When you burn charcoal in a grill, the carbon in the charcoal combines with oxygen in the air to form carbon dioxide. We can represent this reaction with the following chemical equation. Carbon solid plus O2 oxygen gas yields CO2 gas carbon dioxide. In an equation, the formulas of the reactants are written on the left of the arrow and the formulas of the products on the right. When there are 2 or more formulas on the same side, they're separated by a plus sign. The delta sign indicates that heat was used to start the reaction. Generally, each formula in an equation is followed by an abbreviation in parentheses that gives the physical state of the substance. Solid S, liquid L, gas G. If a substance is dissolved in water, it is an aqueous solution. Table 8.2 summarizes some of the symbols used in the equation. Identifying a balanced chemical equation. When a chemical reaction takes place, the bonds between the atoms of the reactants are broken, and new bonds are formed to give the products. All atoms are conserved, which means that atoms cannot be gained, lost, or changed into other types of atoms during a chemical reaction. Every chemical reaction is written as a balanced equation, in order to have the same number of atoms for each element in the reactant as in the product. Now consider the balanced reaction in which the hydrogen reacts with the oxygen to form water, as written as follows. 2 hydrogen 2H2 plus O2 yields 2H2O. In the balanced equation, there are a whole number called coefficients in front of the formulas. On the reactant side, the coefficient of 2 in front of the 8 hydrogen molecule represents 2 molecules of hydrogen, which 4 atoms of hydrogen. A coefficient of 1 is understood for O2, which gives 2 atoms of oxygen. On the product side, the coefficient of 2 in front of the water formula represents 2 molecules of water. Because the coefficient of 2 multiplies all the atoms in H2O, there are 4 oxygen atoms and 2 oxygen atoms in the products. Because there are the same number of hydrogen atoms and oxygen atoms in the reactants as in the products, we know that the equation is balanced. This illustrates the law of conservation of matter, which states that matter cannot be destroyed, created, or destroyed during a chemical reaction.